Hello, my name is Marco Cantù. Welcome to Code Rage 8 and to this session that covers some of the DataSnap architectures, some of the optimizations and speed issues, and some other use cases related to DataSnap. This is not an introduction. There was another session yesterday, and there are other sessions focused on mobile DataSnap. So this is more of an overview of the status of DataSnap and with suggestions, tips and tricks, and some rather new usage scenarios. So these are the topics I'm going to cover. I'm going to spend some time on showing how you can use DataSnap with FireDAC, focus on REST, and just at the very end mention some of the evolutionary plans that we have for the library. As mentioned, I'm the product manager for Delphi at Embarcadero Technologies. In the past, I was a book author, consultant, and trainer for many years following the Delphi product. And here you can also see my contact info. If you want to keep up to date with what I'm doing, follow my Twitter account, and of course also what's happening in the Delphi world. You can follow my Twitter account, and for anything, just feel free to send me an email at marco.cantu@embarcadero.com. So the first part is an overview of the DataSnap architectures, and I've specifically used the plural here because DataSnap actually has evolved over the years by adding different layers and different models. Not all completely obvious and not all perfectly tuned one to the other. Overall, the goal of DataSnap is to provide a multi-tier development architecture. And this is important for desktop, but it's significantly more important for mobile devices, or you don't generally connect directly to a database for security reason, for connection stability issues, and because you want to get into a stateless approach. So you have to connect using some middle tier solution. Of course, there are many out there. You can create your web services with many different technologies. What comes in the Delphi Enterprise or RStudio Enterprise boxes is the DataSnap server. That makes it quite easy for you to expose database data to mobile clients. Now let's try to see what's available as part of DataSnap. In terms of physical low-level connectivity, you can create TCP/IP servers, you can create native HTTP servers, or HTTP servers that use the web broker architecture. That's the good old-fashioned Delphi architecture that lets you connect to multiple HTTP technologies and multiple web services like ISAPI, like IIS using ISAPI, or there was a time it also Apache was available, or you can create standalone web broker HTTP servers using Indy. All of the HTTP and HTTPS solutions support the Open REST and JSON interface, which I'll partially focus on. You can do remote method invocation with TCP/IP, but of course you can do pure REST over HTTP. Now you can also create different types of server in terms of the Windows architecture, the physical module that you are deploying. You can create standalone DataSnap servers. Actually, there are two ways to create standalone DataSnap servers. You can do them when you're creating a DataSnap server or when you're creating a web broker server based on the HTTP server. Now I know that sounds a bit confusing, but that's how it is. And again, it was not really planned, but was like the standalone DataSnap server can have both TCP/IP and HTTP. I can also have them both at the same time. So in theory, you can create a single server that exposes HTTP and TCP/IP And this implies it also exposes a REST interface. Notice, however, that the session objects being created for each of the three connections will behave quite differently. And that's not terribly simple. So I tend to suggest not piggybacking in a single server multiple connection technologies. The other option, as I mentioned, is to create a generic HTTP server, either by creating an ISAPI library as a standalone application. And this means you can not only serve responses to HTTP REST requests to DataSnap, but the same server can also respond by returning JavaScript files, by returning HTML files, and create simple standalone dynamic web service applications. How do you enable all of these features? Well, basically you have three wizards. You can create the DataSnap server wizard. That lets you create either form, console, or service application, and they can use the various connectivity options. Or you can have two slight different versions of the DataSnap web broker application, the other being called DataSnap REST application. The original difference is that the DataSnap REST application would also deploy a bunch of JavaScript and HTML files, but those were later added also to the other two wizards. So a web broker application can be, again, forms, console, or ISAPI. The advantage of having form-based models is that it tends to be the easiest way for debugging, while for deployment you generally want to either use a standalone service, so it will reboot with your server, or go for ISAPI and deploy as part of Internet Information Server from Microsoft. The web broker application, of course, does not support TCP/IP. Now, before we go to the next step, let me show you how you can actually use one of these wizards to create a DataSnap server application. These are the three options. Let's pick the intermediate one, DataSnap web broker application. As I mentioned, you can choose different deployment options, but you will later be able to replace the project file with a different model and the main unit file, the project and the main unit file with another model, and switch from one to the other without having to redo basically none of your code. If you pick standalone, you'll have to pick, or console, you have to pick a port. You can test if the port is available or find an open port. And then you can pick various options, mobile connectors, server modules, authentication, filters. What you cannot select in this web broker application is the support for the JavaScript files. If we go for the DataSnap server, this original standalone version, we can still pick the JavaScript files, the mobile connectors, choose the protocols, and we have a few extra options. Some of these options, like authentication or the protocols, are represented by components that you'll be able to drop into your application also later on. We've seen there are actually multiple scenarios. Now, what is important to consider is not just the low-level protocols like TCP/IP or HTTP, but also consider which operations you can do depending on your structure. On a native DataSnap application, you can use the IAP server interface, the original DataSnap interface, that helps you move and send update requests or refresh requests to dataset-oriented structures. Basically, a data module, a remote data module, exposes one or more datasets from your application. The other technology that's available is remote method invocation. The same remote data module can have a bunch of methods using a variety of data types, and you'll be able to call these remote methods with a direct call or with a public REST URL. However, these different features are not available throughout all options. So if you have only TCP/IP, you cannot use REST enabled approach. But if you go for a pure REST server or a web broker REST server, you cannot use the IAP server interface. So in some scenarios, you have to choose whether you want to go one way or the other, not just because of the connectivity, but also because of the available interfaces. Again, if you want to go for a pure web REST stateless model that would be best suited for your mobile devices, this general suggestion is to pick REST and one of the HTTP server options. In terms of client side, if you're using the IAP server model, you have to use a TSQL connection, although it's not strictly related to DB Express and you can use any technology on the server side. It uses the TSQL connection component. This supports both the IAP server and the remote method invocation. You can use that component to generate, once configured, to generate a proxy, a proxy class with a list of the methods on the client side. But you can also use the TSQL server method objects to connect to individual methods. On the other option, if you're using HTTP as an HTTP server, is to use a REST connection. This supports REST only and has proxy generator support as well. Finally, you can use the new TREST client library to create a barebone but actually quite flexible client connection. So again, also not only you have multiple options on the server side, but you also have different options on the client side that would partially depend on the technologies you've decided to use on the server. Now I know that without demos this might sound a little too theoretical, but again, I know there are other sessions that we go through step-by-step demos, and I don't want to repeat the same content here. So let me move to part 2, which covers some considerations around deployment and performance. In terms of deployment, if you go for a TCP/IP solution, you have the best performance in terms of throughput within a local area network, because you don't have to reconnect every time and you don't have issues with latency, which is required to reconnect or even look up, redo a DNS lookup for the server. So it has good performance, might be the best solution for internal and stable networks, but it requires a specific port, so it's not firewall friendly, might be friendly with your mobile company. It's not ideal for mobile because you might have, again, a non-stable connection. And also it doesn't really scale much because, for example, on the server side, you might have a session object, which corresponds with a bunch of objects on the server that will keep database connections and will keep data sets in cache. So when you're going to significant numbers of connections, it might become slightly more difficult to manage. On the other hand, HTTP and REST have the idea of stateless connections. They tend to be more scalable because you can only use an object on the server side when there is an immediate request and then discard it right away. It works better on unstable networks, tend to be the best solution for mobile, uses generally port 80 or a port that's open for HTTP, and can be deployed both standalone or through an ISAPI module. So there isn't really a preferred way in absolute terms, but I generally recommend HTTP and REST for mobile or multi-device and TCP/IP for local Windows and Mac networks. Now, there are a couple of things that I wanted to show you in terms of performance. We have noticed doing some internal testing that the web broker in the standalone solution tends to have a rather slow throughput. This graph, which was built with an internal tool, shows the difference between using ISAPI with two slightly different internal models and using Indy, which are actually the two lines at the bottom. So as you can see, the throughput, both with a few threads, it starts with 10 threads at the same time, and it goes up to 50. Both with few threads and with a large number of threads, the throughput of DataSnap is significantly better using ISAPI than deploying an Indy standalone solution. That's something you might want to keep in mind while we figure out how to provide even faster options in the future. If you prefer using the Indy standalone solution, notice that there is some difference when you're using a thread pooling approach compared to using the code that's generated by the wizard. So you can actually have like something like 5 times the throughput, specifically when there are very few threads, by using some thread pooling. And this is basically an example of the code you might want to use in terms of your server. The first line is the line that's generated automatically by the wizard to create a server that's inside the server-side form if you're using a form for debugging. What you can add is the creation of an ED scheduler of thread pool, set a pool size. This is the number of threads that will be pre-allocated and kept around, and then assign the scheduler to the server. This code would generally make a significant difference compared to the plain code that the wizard generates. And in the future, we are planning to update the wizard to include this code out of the box. Now, the other area I wanted to focus on is the use of DataSnap with FireDAC. FireDAC, as you may know, is the new data access technology that Embarcadero bought, and in XE5 was fully integrated with Delphi, but we still lack some further integration with some of the other technologies around FireDAC, including DataSnap. Now, as I'm going to show you, you can manually provide this integration, but in the future we plan offering a more integrated solution. Now, there is a classic way you can use to expose a FireDAC dataset, which is via IAP server. You just drop a provider on a remote data module and connect it to the, for example, FireDAC query or FireDAC table. On the client side, it is still easier to use a client dataset, but you can also use a FireDAC mem table. Now, where things start getting interesting, and that's the solution I'm going to show you in a moment, is how you can expose a FireDAC dataset using a REST interface instead. Now, the simplest way is actually to return directly a T dataset from a method. I'm also going to show you how you can create a JSON structure out of it. And on the other side, on the client side, what you want to do is actually to load the data in a FireDAC mem table rather than a client dataset component. So in this demo, I'm going to show you how to create the server that returns either a dataset or a JSON structure with the dataset inside it, with the dataset data inside it, and a client that will use two techniques: the copy dataset function from fdmem table, that's more than copy, is a function that reads from another dataset if the dataset is read-only unidirectional cursor, and Also, how we can use the DBX JSON table reader to read back the JSON source code into a table structure. So let's actually look at this demo. First, the server. The server has a few components. It connects to database. If we look at the code of the methods of the server, you can see that implementing the get dataset returns a T dataset is quite straightforward. You just open a table, optionally open the connection, and you can return it. It will be up to the DataSnap server to convert this object into a JSON representation, including the data of the dataset. If you want to go for a more controlled approach, maybe because you actually want to return multiple pieces of data in the same structure, you can return a JSON value. Or you can return an array of JSON values, or you can return a more complex JSON structure, including a value. Now, if you have a table or query and you want to turn into a JSON structure, that's the code you need, or something similar. Basically, there is this DBX JSON tools table to JSON. You have to provide a reader. A reader is a DBX reader, but you can create a reader that goes through as a sequence of elements through an existing dataset. So you just pass the dataset as a parameter to the reader, saying it's not owned, and pass the reader. You can read only some rows, or you can read all of them. So of course, if you provide maxint and the dataset is at the beginning, you're going to read all of the rows of the dataset. That's the code on the server side that we can actually start and keep running in the background. And now let's look at the client side, which is in this case is actually a VCL application. How we can implement get dataset? That's actually quite straightforward. All we have to do is to call get dataset and open it. Now this is a dataset, an abstract dataset. So if we want to have a mem table and if we want to keep a copy of the data in a cache, what we can do is call the copy dataset function of the FireDAC mem table and pass the dataset as parameter. There are also a few options we can use to indicate how we want to populate the memory table. So that's quite simple because we already start with a dataset. But what if we start with a JSON structure? Well, we grab the JSON, and the first thing we have to do is to convert using this method is to create a reader that will read the JSON and create a unidirectional cursor to read through the sequence. We can wrap this unidirectional cursor, this reader, into a dataset, which hasn't got its own data. The dataset is just an interface over the reader. That's how you can wrap a dataset over a reader. And then we are back to the beginning. We use this dataset and populate the memory table. So there's just one extra step, which is something that the proxy generator will generate automatically for you, which is the creation of the DBX JSON table reader and of a custom SQL dataset wrapping this reader. This is called Delphi will generate for you if you pass a dataset as parameter to a DataSnap client. And of course, we want to make sure this actually works. So let me select the client and read passing the T dataset or passing the JSON structure. as parameter. So finally, I want to spend a few more minutes covering DataSnap and REST. Again, the focus on REST is because it's generally a trending technology. It's an important technology that's been adopted more and more over SOAP and other web services architectures. It tends to be more scalable, flexible, and robust. And it handles scenarios where the connectivity is not consistent. You might actually move from a different network, from a network to another, change your client IP address. The other element in using a fully stateless approach is the advantage of the server. If sessions are very light or there are no sessions at all, if you don't use server-side object caching, if you, again, keep your sessions very light, then you have more chances to be fully scalable. Now, when we are talking about REST, one important element is the fact that you want to implement a clean URL and use the various HTTP methods to perform an operation on an object. So you refer to an object, in this case a contact, using a URL that includes the word contact and the ID. And then you have multiple ways to refer to this object. By default, you're going to read from the object, but you can also use the put, post, and delete HTTP methods to operate on the same element. Now, DataSnap has a specific way of mapping these HTTP verbs to different methods when you want to use the same URL. So in all of these cases, the URL is contact, or the partial URL is contact. When you're doing a put operation or a post operation, you're going to hit the accept contact and update contact methods. While in case of a delete operation, you're going to hit cancel contact. So in a case like this, you'll have an interface like the following. You might want to have a generic way to get a list of objects, but then you have ways to get an individual element, or put, post, delete, that is accept, update, and cancel this element. This mapping is automatic, although you can customize it. So in this case, we have an internal data structure for contacts. It's a contacts dictionary. And by the way, I have to thank Jim Tierney for this demo code. This is how you enumerate the contacts, going through all of the pairs in the dictionary and generate JSON pairs with the key and the actual data. When you refer to one object, we're going to read one of the elements. The get contact is a helper function that just selects an available element and returns it. Or for the other methods, we'll have the ability to, for example, update a contact. When we use the post operation, the update contact, actually the internal name, which is actually more reasonable, is post contact. Post operation has been implemented in this demo as the creation of a new object. Now there is a lot of discussion about post and put, which has to provide the ability to create a new element and which has to provide the ability to update an existing element. Delete is actually quite straightforward, and post will actually create, as I was mentioning, a new object. While update will get the object with a given ID and then update the data structure. So if this is the server that was built for this demo, now if we run this DataSnap server and start it, we can actually have a look at some of its behavior by looking at through this kind of debugger interface to some of the methods. For example, if we look at to contacts, which is the list of, we execute, we get back this JSON data structure. Now we can actually use this same interface, though it's really a bit ugly, to get information about one specific contact, and even go changing this contact to a different structure. So if we now get the list again, we have our modified object here. Of course, this is just for debugging purposes, for testing that there is some behavior. What we actually want to do is to get to the point that we can create a client-side application. This specific client-side application is an Android client. As you can see, it has a data module, just to avoid cluttering the UI. And it does use this new REST client component rather than the traditional DataSnap REST or DBX clients. Specifically, I'm binding to the tserver methods one class. This is the URL. And I'll present this component and kind of show the other more details on the REST side of this demo in a different session for Code Rage 8 tomorrow. But for example, if we go to the list, this is a request that ties to this client. The specific request is for a URL called contacts. And the output of this request is something we can actually display in the UI. Or if we get for the individual request, the inputs will be contact ID, where ID is request parameter. And you can have a default value for it. So this is the cornerstone, and this is used by REST client form. In the user interface, there is the option to pick one of the available methods in this combo box, and then when you click execute, the corresponding method gets executed. Actually, the method is just a helper function that will eventually call another internal method that receives the request object and executes the request object that's tied, the REST request object that's tied to the REST client component. If we actually take this application, we keep the server running, and we connect to an Android device. You can see here I actually changed some of the data. Oh, actually it's now reset. I can go for a different method. I can do a get, for example, and get the object 1 or get the object 2. Let's change it. But of course, I can also go for updating one object. And let's say I want to replace the object 2 with my name. And then I get back to get all. And now you can see that I've changed some of the data. So this is a very simple client that uses the REST components to connect to a DataSnap server. So the last thing, very shortly, there is some evolution that is planned for DataSnap. New web broker options in terms of more optimized servers and more flexible deployment of your DataSnap servers based on HTTP. Further improving the ability to run sessionless, so with no client-related data kept on the server, no sessions on the server, because that makes it possible to actually have multiple servers with load balancing compared to the existing scenario. And we also want to clean and clarify the REST interface, as we've seen in this last demo, the way that HTTP methods are mapped and some of the other areas of DataSnap are very powerful, but not terribly easy or intuitive to use. So I think there is some work we can do to make this cleaner. So in conclusion, DataSnap is a core backend technology for the multi-device strategy that Delphi has. Recommend you to go for ISAPI deployment unless there is a reason to do differently, because that's where you get the best performance today. And I tend to push the use of stateless HTTP with REST and JSON over other older technologies, specifically for mobile client. That's it. If there is any question, just let me know. And you can ask now if you're at the live session, or you can email me at marco.cantù@embarcadero.com. Thanks a lot. Bye.
Okay, Marco, looks like you're still there.
I am.
Excellent. And I made you an organizer, so you should be able to see the questions.
No, go ahead, read them.
How do you map the put, get, post, and delete server-side methods to a user-defined URI, thus overriding the DataSnap predefined URI scheme? I want to define the exposed URIs in the server myself and map those to a corresponding server methods internally. That way I can define a RESTful API, removing the need to provide a proxy to third party.
Yeah, in the various, depending on the actual architecture, but there is a way in either in the HTTP dispatcher, if you're using WebBroker, or the HTTP connector, there's actually an event that is called, and the event will pass you I'm not sure if the URL or the URL element, I think it's the URL elements, like the class name and the method name, and you can leave them untouched or change one or the other. So there is a var response in that method that you can use to do a custom mapping. It's a bit awkward. It's not certainly ideal, but it can be used to have a completely custom mapping. So map to a different class or map to a different object. At the higher level, so within the dispatcher, you can also decide to change or remove the two DataSnap and REST tokens that by default are kind of hard-coded into the system. But there is some flexibility in changing them, not actually removing them, but there's a flexibility in changing them.
Could the HTTP connector produce readily pages to present to browsers, or must the pages be transformed into a PHP?
The current technology in DataSnap has support for, when you're building a web broker app, it has support for the web broker page producer, which is very, very old-fashioned way of building pages. So yes, it can be done, but it's not a terribly pleasant experience. Before joining the company, I had created a simple server script language to actually do a little bit of Delphi-based scripting and processing with the ability to expose RTTI objects. But so something along that line might get into the product later on. But right now there isn't a HTML production technology that's really powerful. There is something, but it's really bare bone. That's what you got when you have like the simple predefined page for the to test the string reverse. But again, expanding that to a real application would be troublesome. But I've in the past, before joining Embarcadero, I actually built a couple of complete websites based on that technology. So there was both the REST backend, but also the page generation and web navigation.
So could NSAPI be used for web broker?
I think that the Netscape API was supported many years ago and has been dropped. I've really no idea if there is if it would like work with the older units, but I kind of doubt. I'm not really sure there's a lot of push in that direction. With what we are considering is resurfacing the Apache integration, the Apache module integration, although Apache today can also have conduits to load ISAPI modules, ISAPI libraries.
What about the support for Microsoft Access as a DataSnap client? Is there an ODBC driver?
No, there isn't an ODBC driver for DataSnap. There is a REST API, so it can be used. You can use as client anything that has HTTP capability, but I don't think that Access is within within those. So
Well,
I don't think that's
for database access, you could use FireDAC, right, to do the database access part, and then data.
Yeah, but this says as a client, so
Yeah.
use Access as a client because Access has its own user interface construction and other things, but I don't think it supports anything in terms of HTTP requests, so I don't think there's a possibility.
So what about OData? Is that supported or planned?
Exposing OData as part of DataSnap client has been discussed. I'm not sure that's really a top priority, but it's something that we might consider for the future. The other side of things is using accessing OData, and that's different. That's something that it is doable with our new REST framework, REST library components.
Yep, he was asking both the access and the OData question. I'm thinking he's from talking about the other direction. So, can one have a TCP/IP and REST server application on the same server?
Oh yes, in fact, you can have like as many TCP/IP and as many web servers as long as you have like a bunch of ports that are available. That's generally the case. So having multiple independent server applications or services or web broker modules is certainly doable as long as you have different ports. What I actually do, I do have a site that hosts a bunch of DataSnap servers, and what I'm doing there, each of them has a different port, but then it gets very confusing having to call like 90, 90, 90, 99, 80, 88, whatever. So what I have actually, I have an Apache that registers each of them as a proxy to a different domain. So when I need something, I just create a new third-level domain, so something.marcocantù.com, and then I map something.marcocantù.com to say localhost 8088, and so that becomes a way to expose a separate DataSnap server with its own domain. And so I do like for each of them. And so they all look like they are different domains, while in fact they are on the same physical machine, all at different internal ports. So with some proxy configuration, you can easily do like domain and port mapping.
Cool. Asapi has issues with the DLL not being locked and requiring a web server service restart to deploy a new build or resolve issues affecting application servers.
I think
kind of Windows service based.
Yeah, I think that there have been some improvements in IIS management, but I'm certainly not an expert on IIS. I've used it very few times. I mean, in real world scenarios. That's why it's nice to have a standalone server, because the ability to, and it's actually the best approach in terms of debugging, having a standalone server.
Mm-hmm.
But on the other hand, when it comes to deployment, we've done some testing in the last couple of months, and we consistently see a significant speed difference. Now, in the longer term, we plan having options to have self-hosted services that are faster than what we have today and more scalable. But today, my recommendation is to do all of the development standalone, and then you can have the same exact project with, I mean, two projects with the same exact modules, and recompile both of them in a single project group, so you can keep your work completely in sync. But deploying ASAPI has some speed advantage.
Now, it's been a while since I've managed an ASAPI or IIS instance, but it seems like there was a architecture where you could actually put something between the DLL and the IIS so that you could then reload the DLL.
Yeah, I think you can. There is a way now that wasn't years ago that you can actually unload and reload a specific module without shutting down the entire server. I think it is supported in today's IIS.
As of XD3, the code get invocation metadata response content type == application/JSON only adds to the content type, not replace it, resulting in two content types in the response header, text HTML and application JSON. Has this been addressed in XE5, or do you have plans to bring that up to headers to HTTP standard?
I'm not sure. I haven't heard about this issue. I've used that approach, and that always worked for me, even returning images and other metadata. So I need to double check. Honestly, I'm not aware of the issue, so it's hard to figure out an answer.
So the next one I can answer, it says, what is Android Screen Viewer? That's actually an application I wrote. You can find it on Delphi.org. If you just search through some of the recent posts, you'll find it on there. Where can you find the component diagram flowchart?
Maybe they're talking about the FireMonkey chart. There's a PDF somewhere. I'll try to find the URL. But if you just look for FireMonkey poster or FireMonkey poster PDF, if that's what they're talking about, component diagram.
I'm guessing that's probably what it is.
Yeah.
The next question is, how about security? We have a session coming up. Is that the next session on security?
Yeah.
Yep, next session's on security. How do I change using REST client or REST request the ID when I make requests using JSON? For example, method, I can't really read the code.
Okay, I can read it. Yeah, it's a bit. I mean, you can manipulate the session ID client side to make sure you send back the right session ID to following request, but that's look like it's a different question. But if you send me like a more detailed email, I can certainly answer that.
When will a Linux version of DataSnap server be available?
I don't know when it will be available. We are seriously considering making it available because we see the need for Linux-hosted services for mobile, but we don't have a time frame. I mean, a public time frame at the moment.
Has the performance of DataSnap when using filters and connection to remote server been improved on XE5?
If it's based on XE4, I don't think so. I know there were some regression introduced at some point, either XE2 or XE3 that have been addressed, but it's not a part of the technology we are really very focused on, also because that's a part of the technology that is not tied to the REST and HTTP, a pure HTTP approach. So we tend to consider more optimal to use other standard technology like HTTPS for encryption.
Okay. It says, how do you show data transfer progress on the client? Is there an event that allows you to get access to that?
There is a possibility to do that. Actually, there are two sides of it. One is the pure data transfer. The pure data transfer, you have to hook into the HTTP request object that behind the scenes, and the HTTP request object has a known progress property that you can manage. It might not be trivial, but that's doable. But that's if the issue is transferring a large amount of data. If she instead is doing some lengthy processing on the server, then you can use callbacks, which is a mechanism that lets you make a call, receive partial results or just information that there is something going on the server, like the physical progress, not just trying to guess how much time that's going to take. And that feedback is sent to the client, and the client can have a real-world program. I mean, suppose that you need an operation that takes like 10 to 15 seconds on the server. You can have like 20, 30 feedback elements, say I am like 1 of 30, 2 of 30, 3 of 30, and so you can actually display a real-world feedback, and also use the same mechanisms to actually cancel a lengthy server-side operation. So that's the callback that was introduced a few years ago.
So it says here, am I able to use DataSnap with Xcode? Is there support for datasets on the client side?
The support for the more complex data structure is limited. You can do basic processing, but if you want to have, like for example, there's not corresponding in-memory data set that you can use, as far as I know. reading in the data. Or else the other alternative that would be likely is actually generate a custom JSON structure from your DataSnap server following one of the, using a structure that Xcode is like, can import more easily.
Roland would like to see a blog post about your Apache proxy trick you talked about.
Okay, I can do that. I think I did it once some years ago, but I might be confused. So certainly talked about that at various sessions. But yeah, I have a bunch of things. Also, I'm hosting quite a few things with that mechanism.
And Robert would like to see some examples of using other DataSnap server choices to build your own pages in code. So another blog post for you there. Steven points out that app pools are great for that. You can refresh the app pool and only affect the one site you are working on. Okay, so this is talking about the IIS restarting we talked about earlier.
Yeah, that's probably the name of the technology we were looking for.
And
thanks, Steven.
Yes, thank you, Steven. Wanse asking if he can import a type library in a mobile application.
If it is a SOAP, a WSDL, yes, we do have SOAP support on mobile. If it means COM type library, I really doubt we have. There is any COM support in either iOS or Android.
There's somebody else saying that Apache and Linux would be great to have.
Yeah, we might have Apache first and Linux next, but I'm personally, I've been a very active user of Apache on basically all operating systems. So
yeah,
it's one of my nice technology, one of the technologies I like.
There's a question about what's the performance of DataSnap REST services compared to other language implementations like Laravel or .NET REST services.
I think we are still not at the performance level we'd like to get to. We are doing some testing right now, and that we're not really done in the past. And again, I showed a couple of graphs from. Actually, it's a testing application written in Delphi, of course, that will actually end up doing a lot of tests and then create a nice graph with the comparison. We of course plan expanding it to compare to other alternative technologies. But on the other hand, given we know that we don't have the speed we wish, we are actually planning and kind of already started development alternative HTTP server-side technologies. There is certainly some non-optimal approaches in DataSnap. For example, the RTTI mapping that we have today, it might not be like the fastest thing, but from what we have seen, the actual bottleneck in some of the external testing and comments that have been done around DataSnap tend to bog down to the HTTP layer and how the web worker is integrated with the HTTP layer, more than like invocation or other specific DataSnap issues. So we kind of think of addressing that first and then looking into other areas to optimize.
Pip, so Alistair Briggs says, for the sessionless evolution of DataSnap, it is not immediately clear to me how a client is authenticated when a request is made to say put update data to database. Does this imply that the client is automatically authenticated in the background, i.e. no login prompt, as the client is moved from server to server in a load balance system, or is this sessionless evolution feature intended for operations in which authentication is not required?
It's both. On one side, if today you don't need authentication, you want to put a public REST service, the fact that for every request you have a session created and remains in memory, or you have to use session close, which is a feature that you can use to make sure that the session is created and then destroyed for every single request. That's time and memory expensive, so it's not something you want to do. But the real goal is to be able to do load balancing and use other techniques. So right now what happens is that there are two issues. One, the session mechanism is you make a request,
you don't have an authentication session, so if it's required, if you have the authentication settings, it asks you for username and password. Once it gets those, it gives you a session ID that is known to be authenticated on the server. So every time you use that session ID, it knows who you are and which are your groups and which are your permissions. Now, this is fine as long as you have one server, because that information lives in memory. So there are two things that we are considering. One, and the technology will be the single one. The idea is you might not want to have a session. So when you get a request, you can use any of the HTTP headers, including a session ID that you can come up with kind of easily. It's just a number, ultimately. But then it will be your responsibility to determine where that is stored, and it could be on a database server that's shared, for example, among multiple physical servers, or it could be another in-memory, another DataSnap server that serves as a backend for the sessions, or like any other possible scenario you might want to implement. The other idea is that some of the session information can actually be sent over to the client in an encoding/encrypted format. So rather than a plain session ID, that's also quite easy to spoof and to track if you don't have like security in mind. It would be nice to be able to get something that's more robust. So some limited information that you send to the client and the client sends it back, kind of authenticating or providing the required information. Of course, this makes sense if the session is extremely small in terms of session data. But in a stateless scenario, your session data will be close to non-existent.
There's another question about if there's a good book for beginners to DataSnap.
I know there is documentation by Bob Swart. I haven't looked at it recently. There is some material of some of my older books, but it's probably a bit sparse. I think there's one of the handbooks for 2009 maybe that should have like a good introduction to the new DataSnap. I mean, it was actually new between 2007 and 2009. And also published some of that material as white papers for Embarcadero a long time ago. So I think there's one or two white papers from me that will provide an introduction.
Yeah, I posted a link to Pavel's, I think it's 11-part.
Yeah, so it's just
yeah, that's a video series.
The Delphi Labs. That's really good for beginners. He starts from the beginning with just a method call, and he's got the videos. He's updated the projects. Some of the videos and white paper are from earlier versions, but a lot of that is the same, and he's updated the projects. So that's a really good place to start. Just go through episode 1 through 11, but then a couple of them, I think number 8 has 2 parts on a web broker and doing mobile stuff with jQuery Mobile. He's got, again, it's a really good tutorial series to take a look at.
And we're going to have to go. Yeah. It's on time for the next session. Wow, there's a lot of good questions there. Thank you, Marco, for being here and answering questions.
Okay. Yeah, I'll be online later on for my second session.
Great. Thanks, Marco.
Okay, bye.